This is a two-part series on diving into MCP Auth with TrueFoundry MCP Gateway. This is session 1. So let's get started. Session 1 is about how TrueFoundry manages MCP Auth at a high level. We'll go over the MCP Auth landscape first and then see what TrueFoundry MCP Gateway enables, starting with the overall architecture, then going to a robust 3-layered auth at TrueFoundry, and finally going over how users, agents, and MCP clients in general authenticate to the MCP Gateway. In session 2, we will go one step further and you will see how to set up MCP Auth in the TrueFoundry MCP Gateway. You will see how to define RBAC and ABAC based access control, how outbound auth from the gateway to the MCP servers is enabled. So how does the gateway connect to the MCP servers? And we will do this with a focus on OAuth specifically, where you will do a deep dive on how TrueFoundry enables OAuth and how does the control plane manage OAuth tokens. And finally, you will also see how you can use MCP Gateway for your agents. So this is our session 1. So let's start. Now, when we think about auth in MCP, there are two distinct aspects. One is authentication, which is more about identifying who the user is. And this is very important because without strong authentication, attackers can impersonate users and leave no trace. Authorization is about what can you do with the access that you have. So having a scoped authorization is very important in general, and you do not want to give over privileges to people who should not be authorized or agents who should not be authorized to do things. So in terms of enterprises, OIDC and SAML are standard for authentication aspects, and OAuth 2.1 is the latest industry standard for authorization. Now, MCP authorization mechanism also varies based on the MCP server. So though OAuth 2.1 is typically standard at enterprises, you might want to have no auth scenarios for public access like calculator MCP server and very simple demo MCP servers. Header auth is for static credential based MCP servers for access control. And OAuth is typically for MCP servers where you're exposing personal data of users like from Slack, GitHub, Atlassian, or you are exposing some proprietary data of your backend microservices where although the data is shared, you still want to have an OAuth layer on top of it for scoped authorization. So if you think about the flow of OAuth, this is how it looks like. This is the front channel where a login is first prompted. The MCP client redirects to the authorization server with a request because by default, it is not authorized to do things. So it needs to get authorized first. This is where a consent screen is then shown to a user because OAuth is typically per user based, right? So the user needs to authenticate and give consent, and they can authenticate via whatever mechanism that they are using, like regular password login, two-factor auth. It can be enterprise IDP, and it can also be the enterprise's consumer IDP, right? Consumers of the agent application. They need to give consent. And then the redirect happens with the authorization code, where the authorization code, the client ID, and the secret are basically exchanged with the OAuth server, giving back the access token. And this access token is basically finally used to access the resources exposed by the MCP server. So if you look at it, what happens is the MCP server only sees the request come in and the access token, and that is all that it has to validate. Now, here you notice that client ID and client secret is also passed by the MCP client to the OAuth server. In a lot of cases, there is something called dynamic client registration that MCP servers support, where the client ID, client secret are generated at runtime even before the OAuth flow is actually triggered. So that's another flow, which is also something which is widely used along with OAuth, where client ID, client secret do not need to be explicitly pre-registered and created. And basically, these are created at runtime. Now, think about this in the context of an enterprise. Every developer managing their own MCP servers leads to gaps in security, visibility, and governance. So without a central control plane, every developer might be managing their auth mechanisms of their own MCP servers. There might be duplication. There might not even be governance as to whether these MCP servers are secure, because a lot of these are publicly pulled, like NPX, UVX packages from GitHub. So a control plane basically centralizes all of the accesses to the different MCP servers through a single endpoint. So MCP Gateway itself is a unified endpoint that basically exposes all of these MCP servers to whatever developers should have access to those MCP servers. And the MCP Gateway is fully managed by enterprises and the admin teams, right? So you get full security, you get full visibility, governance, and you get a centralized registry of sorts with full auth. And this does not have to be on the application side anymore. The MCP gateway takes care and handles all the tokens, all of the management around security. Now with this, let's come to TrueFoundry MCP Gateway. So TrueFoundry MCP Gateway is a central control plane that provides unified access, enterprise-grade security, observability, and guardrails to MCP servers. So it consists of a centralized MCP registry where all of the MCP servers have to be first registered with their respective auth mechanisms. It does a unified token management where, let it be in the case of OAuth tokens, where both the main access token and the refresh token are cached in the control plane of TrueFoundry. And whatever subsequent refreshes needs to be done, those are automatically handled by TrueFoundry's control plane, right? So all in all, it does unified token management in a lot of scenarios where even MCP multiplexing is occurring, where you are picking tools from multiple MCP servers, bundling it all into one, and then just using that single endpoint in your application. So even in that case, the unified token management is done by TrueFoundry. It's having enterprise security and access control, which we will walk through a lot in depth in these sessions. There's an agent playground and code integration as well, where you can link an MCP server. You can easily select a model, select different components, and build an agent very easily with TrueFoundry actually managing the underlying logic. So it's a very easy way to build agents. There are MCP guardrails where you can define guardrails at MCP tools level, MCP server level, right? At very granular levels before the tools or servers are invoked and even after they are invoked. And there's full observability and audit by default. Now, what enables this is, if you look at the architecture, there's a centralized MCP gateway which sits between the MCP clients and the MCP servers. The MCP clients can be agents, they can be IDEs like Cloud Code, Cursor, Codex, and so on. So these need to be registered first. And by default, they are connected as well if it is no auth or API key based. In the case of OAuth, what needs to happen as an additional step is that the OAuth consent flow needs to be triggered and completed. So the user needs to give OAuth access to their personal resources. And then the OAuth token as well as the refresh token is saved by the TrueFoundry control plane, which does the end-to-end token management. So you can think about multiple scenarios here where, let's say you are using a Slack MCP server or a GitHub MCP server, which typically use OAuth mechanisms. This is registered in the MCP registry. Think about Deepwiki, which is a no-auth MCP server. This can also be registered. Hugging Face, which uses OAuth, which can also use API key-based auth, can be registered. You might have internal MCP servers, custom MCP servers, which use your IDP auth. So those can also be registered. And you can have internal MCP servers which have been translated from OpenAPI, which can also be registered in the gateway. Now, the MCP registry basically allows these specific options for registering MCP servers. Most of these are remote MCP servers because that's what the standard is. But you can also create and connect a hosted local MCP server where you need to mention the specifications of the MCP server and it's automatically registered in the TrueFoundry gateway. This is recommended for development use only, right? But typically the remote MCP servers is more standard and that's what you can use for production applications. So you can connect official remote MCP servers where the MCP servers are hosted by the providers themselves like GitHub, Sentry, Atlassian. There's no deployment which is needed here. We have a catalog which is ever evolving and the specific auth mechanisms are also pre-filled as much as possible. So you can easily use this template to create and connect your official remote MCP servers. You can also bring your own hosted and deployed MCP servers and you can just mention the specific auth mechanisms as well as the MCP server endpoint and connect your remote MCP server. You can create a virtual MCP server, which I will walk into more detail, which is more about how do you select tools across MCP servers, bundle it into one, and then create this. So this will give you tool level role-based access control. And the last option in here is the OpenAPI spec based MCP servers, where you can just paste your OpenAPI spec and it will expose that as an MCP server. Now let's go into the 3-layered MCP auth in the gateway. So now let's look at what happens under the hood of how the TrueFoundry MCP gateway actually does the authorization and authentication. So this is the exact same diagram that we were looking at with the layers mentioned explicitly now. Now the MCP clients first need to authenticate to the gateway because the gateway needs to understand who or which MCP client is actually trying to access the MCP server. There are 4 key mechanisms. There is a TrueFoundry API key. There can be an external IDP token, which is issued by your IDP. There's TrueFoundry OAuth. And there is finally one more mechanism where, along with the TrueFoundry or IDP token, you can pass in an additional token which will be used in the outbound auth, which will be actually used to authorize to the MCP server. So there are 4 key mechanisms. The layer 2 is about once the MCP client is actually authenticated, the access control is also managed by the gateway, which basically means that does the MCP client have access to call the MCP server's resources or not. And the third layer is how does the gateway connect to the MCP server? This can again be in multiple mechanisms. This can be with OAuth 2.1. This can be no auth or API key based. This can be token pass-through, where token pass-through means that the inbound token is the same as what is needed for the MCP server authorization. So there's no additional token. Whatever is used for the inbound auth is basically passed as well directly to the MCP server for authorization. And token forwarding is you need to mention an additional token like MCP server token here, or you can also use this along with TrueFoundry OAuth, and that additional token is forwarded to the MCP server in order for authorization to happen. So these are the different mechanisms. These are all independent of each other, which means layer 1, layer 2, and layer 3 are 3 distinct layers, where at each layer, TrueFoundry MCP Gateway is actually providing that robust auth to make sure that MCP clients, they have to pass through each of these 3 layers. Now, a few caveats here, which I would want to point out at this particular point. The TrueFoundry API key can be a user's personal access token, or it can be a virtual account token for service accounts. I will detail this shortly in the next slide even more. The other point is OAuth can only be used with user-specific inbound auth tokens, which means that it can be used with, let's say, a user's personal access token, but it cannot be used along with a virtual account token for service accounts because service accounts are not user-based. So OAuth is used basically for exposing a user's personal data. So it can be used with PAT or external IDP tokens, which are again identifying certain users. And token forwarding is a mechanism which involves passing in an additional token. So by default, this will override the token management system of TrueFoundry. So whatever tokens have been forwarded, those tokens will be the final ones which will be used by the MCP server for authorization, even though there might be something else configured. But if an additional token is forwarded, that is the one that will be passed into the MCP server, and it will override anything else that is configured for outbound auth. Now let's go into inbound auth. Inbound auth, as we discussed, refers to how authentication is done for users to access the MCP gateway. There are 3 kinds of primary buckets here. The first is TrueFoundry users, where users can be added via invite. And when the users are added via invite to the TrueFoundry AI gateway, the TrueFoundry personal access token can be generated by these users. The second way is that individual users can be added via SSO integration, right? So via the organization's IDP itself. And here in this case as well, they will need to generate their own personal access token, which will identify them on the AI gateway. The third option is that on the gateway's configurations, you need to configure and create a virtual account token, which you need to give access to different entities and resources on the AI gateway. So this will basically be a service account token that can be used for applications in production. So it's recommended to use virtual account tokens for applications in production because if users leave the application team, in that case, their personal access token will also expire and it will break the application code. So the virtual account token is typically used for production applications. The fourth kind of users can come as applications end users, which means that they are not necessarily TrueFoundry users. Think about an AI team which has developed an agentic application for use by the company's operations team, which is a set of business users. So the business users will not actually come to the TrueFoundry AI gateway directly. So they need to be configured via external auth, where you need to mention and create the external identity provider and also create external identities with certain claims mentioned. So those claims are basically what will be used to identify the external identity, and you can give access to those external identities to specific MCP servers, models, and so on. So think about the application's user trying to access their own Gmail account. So in that case, their external IDP token, which is generated, will be used for the entire authentication to the gateway. The third bucket is agentic IDEs, where users are trying to access MCP servers through IDEs, where agentic IDEs are directly establishing that connection. So what happens here is TrueFoundry OAuth gets triggered, where TrueFoundry figures out what user is trying to access that MCP server's resources and whether they have access control or not to access that. So TrueFoundry OAuth token is issued, and that handles this entire process. So far, we have looked at what the MCP gateway does conceptually for MCP Auth. Now let's just go over briefly a short demo to see whatever concepts we have covered in action. So what you're looking at here is the MCP registry where different MCP servers have been registered. So as we saw, there are multiple ways to add MCP servers. And once an MCP server has been added, for example, let's go to DeepWiki. You will see that there is a centralized single endpoint to access all of the MCP servers through the MCP gateway. So this is the MCP gateway's URL, which will be the single URL that you need to allow list for access to MCP servers for complete security, governance, and observability. Coming to the inbound auth specifically, let me go to access. Now, the users are currently onboarded here either via invite option, or if there is an SSO integration already in place, which you can configure on the settings via SSO. Once this SSO is set up, where whichever users are logging in via SSO, they will automatically be onboarded as a user, which with the role as member, and they will be able to generate their personal access tokens. Personal access tokens can be generated here in this particular place where you can go to new personal access token, you can set the expiration date and so on. So users will also be able to do a self-service, and as an admin, you can configure what should be the expiry time for personal access tokens and what should be the maximum number of personal access tokens per user. The other thing that we discussed is that virtual account concept, where virtual account tokens need to be created here, which need to be given specific access to different aspects of the gateway like guardrail groups, MCP servers, and within MCP servers, you can give specific roles and role-based accesses to the virtual account. External auth refers to the application's users needing to access the MCP server. So firstly, the identity providers have to be created here, and the identities also have to be created. Then going into the MCP gateway, whenever you are adding, let's say, a DeepWiki MCP server, I can add a collaborator here for access control, and I can select a specific external identity, which will be a user. So this specific external identity will have access to this MCP server. If you want to go into more details of what other features the MCP gateway offers, make sure to look at the deep dive demo, which is referenced in the description below. So this is all about session 1. Make sure to see session 2 for more details on granular access control via virtual MCP servers and very detailed overview of the outbound auth, which means how does the gateway connect to the MCP servers.